Lesson 10.9, Figures on the Coordinate Plane, can be found on page 423. Many of these skills go back to chapter 3. So if you need to have your chapter 3 notes open in order to refresh a little bit, that I would highly recommend that. All right. The world's largest book is well, first I should go over our essential question. How can you plot polygons on a coordinate plane and find their side lengths? So basically it's distance and plotting on a coordinate plane. Both are skills that we learned in chapter 3. The world's largest book is a collection of photographs from the Asian nation of Bhutan. A book collector models the rectangular shape of the open book on a coordinate plane. Each unit of the coordinate plane represents 1 foot. The book collector plots the vertices of the rectangle at point A, which is at 9, 3. Point B is found at the coordinates 2, 3. Point C is found at the coordinates 2, 8. And point D is found at the coordinates 9 and 8. Now remember, it always goes in alphabetical order. X is always first, Y is always second. It's always in alpha order. Mathematicians love order. All right, so now we need to find what are the dimensions of the open book. How big is it? So what 2 dimensions do we need? We need the length because, okay, we need the length and width of the rectangle. All right, so step 1. We're going to plot the vertices and find the dimensions of the rectangle. We're going to complete the rectangle on the coordinate plane. They got us started. So 9, see this would be 9, x, this is the x axis, this is the y axis. 9, 3. That puts us at point A right here. That's 9, 3. Point B, they also plotted for us, 2 and 3. Point C is at 2. X is always first. Y is 8. And you make sure and put the C there. Point D is at 9, 8. All right. Complete the rectangles, plot those points, connect them to form a rectangle. So now we need to connect the dots to make our rectangle. All right. Find the length of the rectangle. Find the distance between A and B. The y coordinates are the same. They're both 3. 2, 3, 9, 3. So the points lie on a horizontal line. If the y coordinates are the same, that means the line is horizontal. Think of the horizontal line passing through A and B as on a number line. The horizontal distance from A to 0, the absolute value of 9 is 9 feet. The horizontal distance from 0 to B, which is 2 here, the absolute value of 2 is 2 feet. Remember from chapter 3 that if both points are in the same quadrant, then we subtract them in order to find the distance. So 9 minus 2 equals 7 feet. And we can even count it. 1, 2, 3, 4, 5, 6, 7. All right. Now, step 3, find the width of the rectangle. So we have find the distance between C and B. This one right here this time. Okay, this is a vertical line this time. So the x coordinates are the same. So the points are on a vertical line. Think of the vertical line passing through C and B as a number line. The vertical distance from C from 0 to the absolute value of 8 is 8. The vertical distance of, so this way, from 0 to 8. The vertical distance from 0 to the absolute value of 3 at point B is 3 feet. Subtract to find the distance from C to B. So we have 8 minus 3 is 5. Again, we can count it to confirm. 1, 2, 3, 4, 5. So the dimensions of the book are, let's see, 7 feet. I was trying to make a 9 there. 7 feet by 5 feet. That's a pretty darn big book. This is 7 feet across. Then this is 5 feet high. Okay. All right, you can use the properties of quadrilaterals to help you find unknown vertices. The properties can also help you graph quadrilaterals on a coordinate plane. Okay, so we're going to do some more graphing. Quadrilaterals, we know, are just 4 lines. 4 lined figures, so like a rectangle, a square, parallelogram. Find the unknown vertex, meaning point, or, a pointy part of a shape, and then graph. So the 3 vertices of the parallelogram, PQRS, are P 4, 2, point Q, 3, negative 3. So they're throwing us into a full coordinate plane this time, using negative numbers also. Point R is at negative 3, negative 3. Give the coordinates of the vertex S and graph the parallelogram. So apparently we don't know what S is yet. We're going to figure it out though. All right, so let's graph what we have first. Okay, so the opposite sides of a parallel. Okay, so here we're discovering our properties first. The opposite sides of a parallelogram are always parallel, hence the name. Meaning they're like railroad tracks. They never ever cross, no matter what. That's what parallel means. They have the same length, right? Or it wouldn't be a rectangle or a square. They have to have, so these two have to have the same length and be parallel, these also, in order for it to be a parallelogram. All right, since the length side of RQ is 6 units. So RQ. Okay, so they're saying, notice that the y coordinates are the same. So the distance from negative 3 to 0 is 3. The distance from 0 to 3 is also 3. You add those together, you end up with 6. Let's plot it here so you can see that. Okay, so P is 4, 2. I'm going to put P right there. Positive 4, positive 2. All right, Q is positive 3, negative 3. Remember, we always go X first. So this is 3, negative 3, and that's point Q. All right, now we're going for R, which is negative 3, -3. So this is R. So the distance from R to Q is 3. This is 3 spaces out from 0. This is also 3 spaces out from 0. So it's 1, 2, 3, 4, 5, 6 units across. That's where that 6 came from. The length of the side SP, so they're saying from wherever point S is to P, and we're going to make this a line segment. Line segments stop. They don't go on forever. SP must be at least 6 units also, because if RQ is 6, SP also has to be 6. Or it's not a parallelogram anymore. It's a trapezoid or something else. So start at point P, move horizontally, meaning this way, horizontally 6 units, because it has to be the same length, to the left. We have to go 6 units this way, because from Q it's 6 units this way. So here we go. 1, 2, 3, 4, 5, 6. This is where S goes. To find the location of the remaining vertex S, plot a point at this location, which we did. Now, what are the coordinates of this location? Well, -2, -2, and +2. All right, draw the parallelogram. This one doesn't follow a handy-dandy line. All right. Draw the parallelogram. Check that the opposite sides are parallel and congruent, meaning they're never going to bump into each other no matter what. They'll never cross over each other. And they have to be the same length. So these are 6. This one is 1, 2, 3, 4, 5. This one is also 1, 2, 3, 4, 5. So we're perfect. So the coordinates of vertex S are -2, 2. All right, explain why the vertex S must be to the left of P rather than to the right. Because basically R was to the left of Q, S had to be to the left of P. It couldn't be over there somewhere, or it wouldn't be a parallelogram, right? So, so vertex S must be to the left of P so that the vertices are in order to create a parallelogram. And the name of that parallelogram is PQRS. Now notice it also has to be in order because PQRS, and then it has to be able to repeat again. If S was over here somewhere, that would be PQR. That doesn't work. It would have to be PSQR. It just wouldn't make any sense. It has to be to the left for it to make sense, so that it's PQRS. All right, describe how you could find the area of the parallelogram PQRS in square units. Well, you take the height. Area equals base times height is the formula for a parallelogram, right? So the base is, what did we say, 6, and the height is 5, because you can just count it. 1, 2, 3, 4, 5. Therefore, the area equals 6 times 5, or 30 units squared, right? We don't know what the unit, they just call them units. We don't know if they're inches or feet or what. Okay, so area equals base times height. 6 times 5 is 30 units squared. Okay, let's do number 1 and then we'll move on to our notes. The vertices of triangle ABC, so there can only be 3 vertices with a triangle because there's 3 sides. So there's 3 vertices, 3 points. A, let's see, is -1, 3. B is -4, -2. C is 2, -2. Graph the triangle and find the length of side BC. All right, so first we graph it. So we go, let's see, -1, 3, and that's A. -4, -2, and that's B. And C is 2, -2. All right, so here's our triangle. All right, there's our triangle. The horizontal distance from -4 to 0. So we're trying to find the length of BC, this length right here. So this is 4. The absolute value of -4 is 4. The absolute value of 2 is 2. Since they're in different quadrants, we get to add. So 4 plus 2 is 6 units. 1, 2, 3, 4, 5, 6. We're right. So basically, the only hard part is remembering how to plot points, X and Y. All right, let's take a quick look at our notes. And we have, if both points are in the same quadrant, these are the same notes that we had in chapter 3. Then subtract to find the distance if they're in the same. If both points are in opposite quadrants, add to find the difference, the distance. So here they're in different quadrants, therefore you're going to add. In this example, they're in the same quadrant, therefore we're going to subtract. So, so that would essentially be 4 minus 1 is 3. 4 minus 1 is 3. 1, 2, 3. Over here we have, what, 3 and 1. 3 plus 1 is 4. 1, 2, 3, 4. All right, good luck.